Hi dear students. So in the last section we have started our new chapter, that is the motion in a straight line. So we have discussed about the displacement, path length, the rectilinear motion, then the XYZ axis, the coordinate system frame of reference. Actually the coordinate system that we are using to define the position of that object. And afterwards we have discussed about the displacement or the path length. First of all, the path length. Path length is the total distance covered by the object throughout its motion. So that means, suppose if the body is starting from the origin, that is at the point O, so 0 to a distance 120 meters, then the displacement, the distance travelled or the path length travelled will be considered as 120 meters. And if it turns back, reached at 60, then 120 plus 120 minus 60, that is 60. So 120 plus 60 meters will be the total path length. Or suppose here it is 80, suppose consider 80 over here. So that person or the object is travelled from 0 to 120 and it is returning back to 80. Okay. So the total path length travelled will be 120 plus this distance. This distance will be 120 minus 80. So that will be, which will be is equal to 40 meters, and the total path length will be is equal to 120 plus 40, that is 160 will be the total path length. So path length, regarding the path length, we have already discussed that one. And regarding the displacement, okay, let us come to the displacement. So the displacement, suppose the first case you just consider the displacement if the body is starting the motion from origin till the point 120, that is consider that point as A. So the displacement between the initial and the final position will be, this is 0. So x2 minus x1, 120 minus 0, that will be 120 only. Now the body is starting its motion from 0 to 120 and again it is returning back to 80. So here the initial position is at 0 and the final position is at 80. So final position x2 minus x1, that is 80 minus x1, then the displacement will be is equal to 80 meters, but at that time the path length travelled will be is equal to 160. Okay. So the difference between path length and the displacement. Other differences, the major differences are, the path length cannot be 0, but the displacement can be 0. Displacement can be 0. So suppose if the body is starting its motion from 0 to 120 and again it is returning back to the same point, then the displacement will be 0, but the distance or the path length will be 120 plus 120, that will be 240 meters. Displacement is 0, but the path length is total 240 meters. But at that time the path length cannot, if a motion happen or movement happen, then the path length will not be or cannot be 0. Displacement can also be 0. The next one, the path length is a scalar quantity, but at that time the displacement is a vector quantity. But here we are not giving the notation of vector, but instead of that, because we are considering only one axis or the motion in a straight line. So just with the help of the signs plus and minus, we will define the direction. If it is plus sign, that is the direction of movement is from left to right. Okay. If it is minus, the movement is from right to left. Okay. Suppose if the motion is happened over here from 80 to 60, that is from right to left, that x2 is 60 and x1 is 80, x2 minus x1 will be minus 20. That means the movement is happened in the direction left, because the displacement value is negative, minus 20. Okay. So these are the things that you have discussed in the last class. Now we will discuss about the position time graphs. Majorly the object is at rest, object is in uniform motion and object is in non-uniform motion. First of all, the object is at rest. At rest means the object is not moving at all. Okay. The object is not at all moving. So here you can see the time, the x-axis we have, on the x-axis we have taken the time, and on y-axis the position is given. As the time increases, you can see the position is a constant value only. There is no change in the position. It is remaining constant even if the time is increasing. Okay. Suppose 1 second, 2 seconds, 3 seconds, 4 seconds, but still you can see the x value is remain constant for all those time intervals, isn't it? That means even if the time is increasing or even if the time is changing, the position of that object is not changing. That means the position is constant and the object is at rest. So this is the graphical representation of the position and time for an object at rest. Now let us come to the object which is in uniform motion, the position time graph of an object which is in uniform motion. So uniform motion means the object's position is changing equally. Okay. Equal change in the position of the object for equal intervals of time. For an example, if you are considering 1 second, 2 seconds, 3 seconds and 4 seconds, the position of the object at 1 second was 0. The time intervals are, okay, these are equal time intervals of 1 second, isn't it? 1 second and 2 seconds the gap is 1 second, 2 second and 3 second the gap is 1 second, and 3 second and 4 second the gap is 1 second. So interval of time is equal. Now the position of the object at 1 second was 0, at 2 seconds it is at 8 meters, and 3 seconds it is at 16 meters, and at 4 seconds it will be at 24 meters. If the position and the time interval are like this, then we can say the position or the object is in a uniform motion. That means in equal interval of time the object is covering equal interval of distance. Okay. At the 2 second it was at 8 meters, 3 second the next 1 second gap it is at 16 meters. So that means for 1 second gap, if you are considering a 1 second gap, the displacement happening is 8 meters, isn't it? For the first 1 second gap, 0 to 8 meters, 8 meter displacement is happened. From next 1 second, that is 2 second to 3 second, the gap it is 1 second. For that 1 second, the displacement happened till 16, that means 16 minus 8, 8 meter displacement is happened. Again 4 second and 3 second in between, at 3 second the body is at 16 meters, and at 4 seconds the body is at 24 meters. So that means the difference between the time interval is so it means the difference between the time it is 1 second, that is the time interval is 1 second and the displacement it is 8 meters, 8 meter, 8 meter, 1 second, 1 second, 1 second. So for equal interval of time, equal displacement, equal intervals of displacement if it is happening, then you can say the object is in uniform motion. Okay. So, the uniform motion, the graph will be like a straight line, okay. A straight linear line will be there. Here you can see that suppose 1 second the value will be 1, then 2 seconds the value will be 2, 3 seconds the value will be 3. Likewise, you will obtain the graph. Okay. If you want, you can try a graph for 1 second, 2 second, 3 second, 4 second with the 8 meter displacement. Okay. Now let us discuss about the average velocity and the average speed. So, you know that if a body is moving, that means by time the position is changing. Okay. So, but with how much speed the position is changing, for defining that one you should need some quantity, isn't it? That is known as the average speed. Means at which speed or at which how faster the position is changing with the change in time. For that purpose we are using the physical quantity average speed. And suppose a body is beginning its motion from a point x1 at a time t1 and it ends at a point x2 at a time t2. Okay. So, x1 was the beginning position and the time was t1. Now, the position of the body is at x2, that is the final position, and the time, now the time it is t2. Then the average velocity delta, sorry, the bar v bar, okay. The bar sign is actually for representing the average of velocity. Average velocity will be is equal to delta x by delta t, where delta x we have already studied that delta x is the displacement, isn't it? Displacement. So, here delta x is equal to x2 minus x1, x2 minus x1 divided by the time interval, that is delta t, or the time taken for that movement. So, that will be delta t, that is t2 minus t1. Okay. So, this is the equation for the average velocity. So, average velocity will be given as delta x by delta t. Okay. You can find the average velocity with the help of the displacement and change in time as delta x divided by delta t, where delta x is equal to x2 minus x1, that is the displacement, and delta t is equal to t2 minus t1, that is the time interval or the time taken for that movement. Now, the average velocity is also a vector quantity. Average velocity is also a vector quantity, but we are not giving any vector notation over here, but with the help of the negative and positive signs we are defining the average, defining the direction of the average velocity as the same in the condition of the displacement. If it is positive, the velocity is increasing, and as well if it is negative, the velocity is decreasing. Okay. As well, the x2 minus x1, if it is positive, that means it is increasing in the direction of x axis. Okay. And if it is negative, then this is the value is decreasing in the negative x axis direction to the right to left. Okay. So, regarding that one, so here also we are not the delta, so average velocity is a vector quantity, it is having direction as well the magnitude. And let us come to the unit of the average velocity. Here x2 minus x1 is actually meter, isn't it? x2 meter minus x1 meter. So, the unit will be meter over here divided by t2 seconds minus t1 seconds will be seconds. So, meter per second is the unit of average velocity. meter per second is the unit of average velocity, but in common use we are using the kilometer per hour value also, the unit also. These are the two major units of average velocity. One is meter per second and another one is kilometer per hour. The conversion of meter per second into kilometer per hour and kilometer per hour into meter per second, that we have already discussed in the last chapter. You just find that one, okay. Refresh those things, okay. We need those values of conversion of the kilometer per second into kilometer per hour and kilometer per hour into meter per second. We have to use those things in this chapter. So the applications will be there. So remember those values. Now, suppose consider the body is at a rest. Okay, before that one, in your textbook one graph is given. Okay, graph is given. So in that graph, this is the x direction. X means the position, and here you are having the time t. Okay. So and a darkened portion is given, isn't it? A darkened portion is given. Okay. Now suppose in a graph, if the values are given like this, then how will you find out? How will you find out the average velocity? How can you find out the average velocity? Okay, we know that x2 is the position at a particular time t2 and x1 is the position at a particular time t1. You have to find the geometrically, if you are saying, okay, you have to find out the slope of the graph. Slope of the graph, then you will get in this case, if the xt graph it is there, then if you are finding out the slope, then you will get the velocity, average velocity. So this is on this axis you are having the position, this is the y axis and this is the x axis. Okay. Now here if you want to represent the position of this point, okay, the point, now I am just naming the points as A, B and C, okay, A, B and C. So slope will be AB by BC, okay, that will be the slope. So you have to find out the value of AB and BC first of all. So here suppose if we are considering the AB, the coordinate will be is equal to 727.4 and here the B will be 710, okay. This one will be 510 and this one will be 710, okay, this will be 510. Okay. In such a way the x axis value and comma the y axis value, okay. In such a way you have to represent the coordinates. Now let us come to how the slope, how to find out the slope. So here the x is a constant value over here, but you can see the y is varying for this one, okay. So AB, the distance of AB will be the difference in the y coordinate value. So that is x2, here this one is the x2 value and this is the x1 value. So AB will be is equal to x2 minus x1, AB will be is equal to x2 minus x1. So we can say the V bar, average velocity, will be is equal to the slope of the graph, that will be is equal to AB by BC, where AB is equal to x2 minus x1, the position of the object at the final position x2 and initial position. You just want to consider 2 points, okay. You are considering 2 points on the graph and considering the first point with the x1 t1 and considering the second point as x2 and t2. So x2 minus x1 will be is equal to 27.4 minus 10 divided by BC, where BC is equal to t2 minus t1, okay. That is actually delta x divided by delta t, x2 minus x1 divided by t2 minus t1. So, T2 minus T1 will be is equal to, here the T value it is 7 and here it is 5. So, 7 minus 5. So, that will be is equal to 17.4 divided by 2, isn't it? So, which will be is equal to 8 point something will come, 8 point, what is the value given? 8.7, 8.7. The unit will be meter per second, meter per second. Okay. So, these are the major things that you have to remember regarding the average velocity. First of all, the definition: average velocity is defined as change in position divided by the time interval. Okay. So, and it is denoted as V bar, that will be is equal to delta x divided by delta t, and that is equal to x2 minus x1 divided by t2 minus t1. x2 is the position at time t2 and x1 is the position at time t1. Here in this graph the same thing is happening. x2 is the position at time t2 and x1 is the position at time t1. So, x2 minus x1 divided by t2 minus t1. Geometrically that is the slope of the graph, and here that is x2 minus x1 divided by t2 minus t1. Okay. And the unit of the speed, it is meter per second, but commonly we are using the kilometer per hour, and the average velocity is all a vector quantity too. Average velocity is a vector quantity which is having magnitude as well the direction. Okay. So, these are the major things. Now, suppose if the body is at rest, that means the xt graph, we have already seen the xt graph, that will be like this, x and t. X is constant. So, delta x will be is equal to 0. The position is not changing. So, V bar will be is equal to delta x divided by delta t, you know that, delta t. Okay. So, as the delta x is 0, the average velocity will also be 0. So, for a body at rest, the average velocity will be 0, and if you are considering a body in uniform motion, okay, a body in uniform motion, if you are considering, then the velocity is increasing equally or equal interval of velocity, the displacement will equal, displacement having equal intervals for equal intervals of time. Okay. So, that means the linear graph you are having. Okay. Now, consider a position. Okay. So, 0, 1 second, 2 seconds, 3 seconds. The position should be increasing equally. Okay. So, if 0, I am taking 2, 4, 6. Now, let us consider the position 2 and 4 initially, that is x1, t1, x2, t2. So, the V bar will be is equal to x2 minus x1 divided by t2 minus t1. With an example we are just explaining. Okay. So, here x2 will be is equal to 4 minus 2 divided by 2 minus 1, 2 minus 1, this is second, 2 minus 1. So, you can see the V bar will be is equal to 4 minus 2 is 2 divided by 2 minus 1 is 1. So, which will be is equal to 2 meter per second. So, now we have considered 2 and 4. Instead of that, if you are considering the 2 and 6, the position 2 will be x1 and position 6 will be x2. So, this will be t2 and 1 second will be t1. So, where x2 minus x1 divided by t2 minus t1, the v bar will be is equal to x2 minus x1 divided by t2 minus t1, sorry, 6 minus 2 divided by 3 minus 1, which will be is equal to 6 minus 2, it is 4 divided by 2, which is equal to 2 meter per second. That means, for a body with a uniform motion, the velocity will remain constant. The velocity will remain constant with a body which is in uniform motion. For such a body, the velocity value will be equal. Now, you can consider the 2 and 4 also, 2 and 4 also you have considered, you can consider, if you want, you can consider the 0 and 6 or 4 and 6. For all those values, the delta v bar value will be is equal to 2 meter per second, that is the average velocity is constant. So, that is regarding the uniform motion and the velocity in the case of the uniform motion. Now, so position at rest, the v will be is equal to 0, that means there is no displacement, delta x will be is equal to 0. Now, let us consider another graph, that is t x. The graph is like this. That means whenever the position, the time increases or time changes, the position is decreasing. That means it is moving in the left direction. Okay. In such cases, the x2 minus x1 value will be negative. Okay, x2 minus x1 value will be negative, and the value of the velocity will also be negative. Such motion are known as retarded motions. Okay. Wait 1 second. In such cases, suppose if you are taking this one as time t1 and this one as time t2, then the position this will be x2 and this one will be x1. Okay. So, t2 minus t1 and x2 minus x1, you can see the x2 is a small value than x1. So, x2 minus x1 will be a negative value, and hence v bar will be x2 minus x1 x2 minus x1 divided by t2 minus t1, where x2 minus x1 is a negative value, hence the v bar will be a negative value, but t2 minus t1 is positive only. Okay. So, a negative divided by a positive will be a negative value. So, that means the value of average velocity is negative 1, that is the body is moving with a negative velocity, retarded motion, we can name that one as like the rule. So, now let us come to the other term, that is known as the average speed. Actually, the average velocity, we are just taking 2 points in between the entire path, isn't it? X2, x1. It cannot be, it may not be the initial and final points. Okay. Suppose if the motion is in this such a way, that is 0 to 120 meters. For taking the average velocity, we are just considering in between 2 points x2 and x1. Likewise, we are just considering. So, suppose if you want to find out the average velocity which was happened in the entire path, then you have to consider the, instead of this displacement, you have to consider the entire distance travelled. Entire distance travelled divided by the entire time taken for that transport or the travel. Okay. So, that is known as the average speed. That is known as the average speed. So, now we will discuss about the average speed. Okay. So, average speed is defined as the total path length divided by the total time interval during which the motion has taken place. So, that is the definition of average speed. So, but in the case of that average velocity, it was the displacement divided by the time interval taken for that displacement. But here we are considering the total path length and the total time interval. So, average speed is equal to total path length divided by the total time interval. Where average speed can be is equal to, maybe it can be also equal to the average velocity if the direction of the motion is the same. If the direction of motion is the same, then the average speed and average velocity can be equal. If the direction is changing in between, then the displacement, okay, displacement and path length will be different, isn't it? So, we have already discussed that one when we have dealt with the displacement and path length. So, here in this case you have to complete consider the entire path, okay, for that average speed, but the displacement, just the displacement whichever the happen, that you have to consider for average velocity. Okay. So, then the values will change. Okay. The average velocity value will be lesser than the average speed value. The magnitude of average velocity value will be lesser than the magnitude of the average speed value. So, average speed value will be having more magnitude, okay, if the direction is changing. So, one example is given, you just go through that example, okay, one time, and you can take the notes also in that video section. Sorry, actually I have to tell you that one in the beginning section, but I did not tell. So, I will send you the PDF, just take the notes from that PDF. Okay. So, I think these much things are clear. So, average speed, average velocity, displacement, path length, then the coordinate system, all those things, I think you are very familiar with those things now. Okay, then we can wind up the class section now. Okay, thank you.